Suppose we have a circuit like this and we are asked to calculate the currents in the branches I1, I2, this is main current I5, suppose that it flows this way, I3, not I5, I3, I4 and I5. Well, we can use different methods. We can write, we have three meshes, four nodes, but I think the best method, the fastest I think, is to do a delta star transformation and then calculate the equivalent resistance, and using the current divider we can calculate I4, I5 and then I1, I2 and I3. So let's do the first transformation. We transform this delta into a star, or this delta. You can choose whichever is fine for you. Okay, let's take this one. This one we can change it to R3 prime, R1 prime, that's it, R1 prime, and R2 prime. This star, we change it to, I can draw it here if you like. I'm not going to put, this is the star. We're going to, this is R3 prime, R2 prime and R1 prime. Let's calculate, and later we have R4 and we have R5 here. Okay, and we come back to the source. Well, if you remember, I did a film about it. R1 prime, this one is R1 prime is R2 times R3, over the sum of the three, R1 plus R2 plus R3. R2 prime is R1 times R3 over the sum of the R's. R3 prime, which is this one, is R1 R2 over the sum of the R's. So the sum of the R's is 15 plus 5 plus 7, it's 27. So R2 times R3 times R2, this is 15 times 5, it's 75 I think. 15 times 5, 75. R1 times R3, it's 35. R1 times R2, 15 times 7, it's 105. So it means R1 prime 75 divided by 27, it's 278 ohm. 35 divided by 27, this is 130, we can say 1/3 point here. Use point English, the American and 105 divided by 27 will give us 3.9 ohms. So here we have 3.9 ohms. R2 prime is 1.3 ohms. Point. And here we have 2.78 ohms. Okay, we completed the circuit. Now we can calculate the equivalent resistance. The equivalent resistance is R3 primes, which is in series with R2 prime plus R4, which is in parallel with R1 prime plus R5. This is our equivalent resistance. R3 prime is 3.9 plus R2 prime plus R4. R4 is 30, 16, so it's 31.3 in parallel with 18.78, and these two will give us 31.3 times 18.78 over 31.3 plus 18.78. So the equivalent resistance will be 31.3 plus 18.78. This is 50.08, and 31.3 times 18.78. This is 587.8. Okay, divided by 50. This will give us 11. 3.9 plus 11.76, let's say, ohms. So the equivalent resistance will be 15.65 ohms. And from here we can calculate I, the main current. I is equal to V over RE. 125 divided by 15.65, and this is about 8 amps. Okay, 8 amps. So this is 8 amps, and now we can calculate I4 using the current divider, because these two are in parallel, so we can say that I4 is equal to these resistances R5 over R1 prime plus R5 plus R2 prime plus R4 times the main current we just calculated. Here you have 18.78 over 18.78 plus 1.3 plus 30. So this is 50.08 times 8. So it's times 8 times 18.78. It's 3 amps. It means that I5 here, the current flowing here, will be I minus I4. I minus I4. So it's 5 amps. Here flows 5 amps. Okay. Okay, 5 amps. Here we have 3 amps. Here we have 8 amps. Now we can calculate I4, I1 and I2. I1, to calculate I1 we have to know the drop here and the drop here. VR1, it's VR2 prime, the drop here, plus the drop here, VR3 prime. So it means that R1 times I1 is equal to VR2 prime, R2 prime times I4, current flowing here, plus R3 prime times the main current that flows here. So 3.9, 1.3 times I4, 3 times 3 plus R3 prime 3.9 times 8 is equal to 3 times 1.3. This is 3.9 plus 3.9 times 8. This is 31.2. So plus 3.9 is 35.1. And now we can calculate I1. I1 is equal to 35.1 divided by R1, which is equal to 7. 35.1 divided by 7 is equal 501 amp. Having I1, I can calculate I2. I2 is I minus I1. I is equal to I2 is equal to I, because I is equal to sum of the two. So it's 8 minus 501. So I2 is, we can say about 3 or 2.98 amps. We have calculated I1, I2. We are left to calculate I3, knowing that I1 is equal to I4 plus I3. I3 is equal to I1 minus I4. I1 is 5.01 minus I4. We have calculated earlier, and it's about 2 amps. Okay, so it means that I1 is